Here's the uncomfortable truth. In AI, the model is often not your product. The API is.
That sounds harsh, but it's useful. An API in AI is the interface your code uses to talk to a model, without you hosting or training that model yourself.
So when people say we added AI, what they often mean is we made an API call.
Exactly. Your app sends input plus instructions to an AI service. The service runs the model and sends back output like text, labels, embeddings, images, or tool calls.
That sounds almost too simple. Why should a programmer care beyond the buzzword?
Because this changes what you build and where the hard parts move. You spend less time on model internals and more time on input design, output validation, latency, cost, and failure handling.
Give me a concrete case.
Say you run a support platform. A user submits a ticket. Your backend calls an AI API to summarize the issue, classify urgency, and draft a reply. No model training, just requests, responses, and application logic around them.
So, the API is like a remote function call, except the function is probabilistic and expensive.
That's a great way to think about it. It behaves less like a strict library function and more like a smart service with variable output, limits, pricing, and edge cases.
And that's where things get dangerous, right? Programmers expect deterministic behavior.
Right. One common misunderstanding is thinking an AI API is just another endpoint that returns the correct answer if you hit it properly. It doesn't guarantee truth. It generates a plausible result based on patterns.
Meaning, if I build like it's a calculator, I'm going to ship bugs with confidence.
Possibly worse than bugs. You can ship wrong answers that look polished, leak sensitive data if you pass too much context, or create workflows that fail silently because the model output drifted.
Let's make that real.
Imagine a recruiting tool that sends resumes to an AI API and asks for top candidates. If you treat the output as ground truth, you may automate bias, misqualified people, and have no audit trail for why the model ranked them that way.
So, using an AI API isn't just calling intelligence, it's accepting uncertainty as part of the software contract.
Yes, and good programmers design around that. They constrain prompts, define schemas, verify outputs, add retries, set fallback paths, and keep humans in the loop where stakes are high.
Walk me through what programmers actually do day to day with these APIs.
3 big patterns. First, generation. Write code, draft emails, summarize documents. Second, extraction. Pull structured data from messy text. Third, reasoning workflows. Let the model choose tools, search data, or plan steps inside a bounded system.
Bounded system sounds important.
Very. The winners won't be the teams that simply ask the model open-ended questions. They'll be the teams that build tight systems around the API so the model operates inside rules, permissions, and measurable outcomes.
Example?
A finance app can use an AI API to explain a transaction in plain English, but it should not let the model move money freely. The safe design is model interprets intent, normal code checks permissions, and deterministic systems execute the transfer.
So the API matters because it shifts software from pure logic to supervised judgment.
That's the key shift. APIs make powerful models accessible to regular developers, which lowers the barrier fast. But that also means advantage moves to the teams that know how to evaluate, monitor, and contain model behavior.
And if you don't?
Then you're not building AI features. You're outsourcing critical behavior to a black box and hoping for the best. That gets expensive, brittle, and risky very quickly.
So what is an API in AI? In one line?
It's the programmable doorway to a model. And your real job is not opening the door. It's controlling what goes in, what comes out, and what happens if the model is wrong.
That's the power shift, then. Not who can talk to AI, but who can make AI behave.